So here's where we had left off last time. This was a discussion about the supplier interface. I'd given you a couple of examples of suppliers before, just kind of demonstrating how a supplier returns a value but doesn't take any parameters, although you can often pass various variables into a supplier lambda by using effectively final variables, as we talked about before. What I'm going to do now is talk about another variant of a supplier called a constructor reference, which is really quite interesting. So this example, which is the EX7 folder in my GitHub account, shows how you can use a couple of different forms of constructor references. So you'll see here that we have a class called CRDemo, where CR stands for constructor reference demo. And in this class, we have a method called zeroParam constructor ref. So this is illustrating how to use a constructor reference that doesn't take any parameters. Here's how we do this. We define ourselves a supplier. Remember, supplier is a generic class, so we have to instantiate it with something. We instantiate it with the CRDemo class, just to make it easy. We call this variable factory. You'll see why we call it factory in a second. And what we do is we initialize the factory supplier with CRDemo : new. CRDemo : new is the syntax in Java 8 for a constructor reference. And for this particular case, it's going to be the zero parameter constructor. That's a constructor that doesn't take any arguments, as the name implies. And you can learn more about constructor references at the link down here. Once we've got ourselves a supplier instance called factory, then all we do is we say factory.get. And factory.get, because remember, get is the name that you use for suppliers, it goes ahead and creates a CRDemo object, an instance of the CRDemo class, using the constructor reference that we passed or used to initialize the factory in the first place. So this will make a CRDemo object, which we call CRDemo with lowercase c. And then once we've got that, we go ahead and we print the results. So print will go ahead and print out this string, which is what would be initialized by all this stuff, in order to print the result. So we make ourselves a CRDemo instance, and then we say CRDemo.print, and that will go ahead and print things out. OK, so that's a pretty simple example. That's a zero parameter constructor reference. That's kind of the default. But you can do so much more with constructor references. And this is a more complicated example, but it shows the power of the way this works. So this example, which is also part of the same folder, illustrates how we can have constructors with an arbitrary number of parameters. In this particular case, we're going to have a constructor for 3 parameters, a string, an integer, and a long. And here's how we're going to do this. We're going to define ourselves an interface. This is our own interface. We made this interface. I call it try factory, try being 3, as in like tricep or tricycle or something like that. So try, TRI means 3, and this is a factory that's going to be used to make an instance of something that has 3 parameters. Now, what's interesting about this is you can see that the actual interface has 4 type parameters. A, B, and C are just the formal parameters for whatever types we're going to pass into the constructor, and then R is the return value. So we'll see this of method will be a factory that takes 3 parameters and returns an instance of whatever we pass in as the 4th parameter to the generic. So that's kind of the big picture. We have this thing called try factory. Now let's come down here and look at the 3-param constructor ref method, which is just there for testing purposes. And you can see here that it takes CRDemo : new, same name as we had on the other slide. Remember on the other slide we called it CRDemo : new, except that time it was referring to the single or the 0 parameter constructor, the default constructor as we might call it in C++. So this new actually refers to this constructor. And this, as you can see, takes 3 parameters, a string, an integer, and a long. And so what we do is we make ourselves an instance of try factory, again called factory for lack of imagination, and we give it a string, which corresponds to this, an integer, which corresponds to this, and a long, which corresponds to that. And then the final and 4th parameter is the name of the class we want to make, which is CRDemo. And so that is now going to be stored here. And what's interesting is when we say factory.of, then we can pass it parameters. The answer is 4, 2L, or whatever. And then when we call print on this thing, it'll go ahead and make ourselves an instance of a CR demo, which stashes away the parameters into mString, which is the field we had defined earlier, right here. And, whoops, and then it calls print, and that goes ahead and prints the results. So this is just demonstrating that you can use the mechanisms in Java to have constructor references that will access sort of arbitrary length constructor parameter lists, as opposed to just the single one that comes by default if you use the supplier. Any questions about that? Yes, sir. Oh, great. Yeah, good question. So why the heck do you need constructor references in the first place? It's not so obvious from this example. This example is pretty simple, but there are situations where you actually want to parameterize methods with the type of object you want to make. And I should probably improve this example so it makes that point a little bit more clear. But one of the cool things here is you can, once you create this thing, once you create this supplier, once you create factory, supplier, CR demo, you could then pass that to other functions in your program, and then they could use that factory to make objects. And that way you could have one piece of code that knows how to make something, but you could pass it different types of suppliers with different kinds of objects to make different kinds of things. So the big picture view here, the big question, why the heck would you ever do constructor references? Since you can just call a constructor directly, you do it if you want to write code that will be parameterized by the type of thing that can make an instance of an object. And there are lots of examples. I'll show some examples. I have some examples I'll show later that'll make that point more clear. But the big picture view is, if you want to parameterize creation, this is a way to do it. But to your other question, if you just want to make one of something and you don't need to parameterize it, just call a regular constructor the way you normally do. But if you want to parameterize making something by using sort of like the factory method pattern from the Gang of Four book, then constructor references can make it easier to do. That's a really good question. I need to clarify that because it's not really very clear. Okay, the fifth type of functional interface we're going to look at is something called a consumer. Remember, a supplier was used to generate stuff. It was used to produce it. And surprise, surprise, a consumer can be used to receive stuff. And as you'll see, when we look at the consumer interface, it's also parameterized by type T, but it has a method called accept that has no return value. It simply takes an instance of type T, so it accepts it. So you can think of a supplier as something that produces a value, and then you can think of a consumer as something that will receive it and handle it in some way. So a consumer might be, sort of a subscriber that'll receive the results of something. So let's take a look at an example. We've seen this example before in a different context, and now I'm going to focus on a different part of the example. So what we're going to do is we're going to make ourselves a list of 3 threads that are initialized with different names of our good friends, the Stooges. And then we're going to go ahead and we're going to print out the names of the threads using the for each method on list. And so there's as you can see, there's a for each method that's part of iterable. List implements iterable ultimately. And now we're going to print the results out. And we're going to be passing in a method reference system.out : println, which is just a way of referring to the println method. Here's what the for each method looks like. If you were to look far enough up in the source code of Java, you'd find an interface called iterable. And in the iterable interface, you'll see there's a for each method. And lo and behold, it's defined as default. If you recall from our discussion, I think maybe the first day, we talked about interfaces in Java. And I talked about how in earlier versions of Java, an interface could just be a place for defining method signatures. But then starting with Java 8, you could also have these things called default implementations in interfaces. So this is an example of a default implementation. And the reason it's here is because lots and lots of things in Java, lots and lots of collections want to be able to use the for each mechanism in order to iterate through the contents of the collection. And this is no different. So what you can see it does here is for each element In the collection, it's going to apply the action that's passed in as a consumer. And in particular, it's going to call the accept method on the action that's passed in. So let's take a look and see how this works in the context of our example, where we're printing out the names of the stooge threads. So here, what's passed in is the action is system.out::println, which is a method reference, which matches the consumer signature. And down here, what you see we do here is we're going to iterate using a for each loop in order to iterate through each element and call the accept method. And what that'll do under the hood is accept gets replaced with println, because that was what was passed in as the action, as the argument. And that'll go ahead and print out each element. That reminds me, I forgot to mention this when we were talking this morning. So in your programming solution for assignment 1A, there's a couple of places where you got to iterate through something. I'd say in general, try to avoid using loops wherever possible, or avoid using explicit iteration. Instead, call lower level helper routines like array copy or copy of or so on. There are a couple places where you've actually got to loop. And there's a couple of choices for how you loop. So one place where you probably need to loop is index of. So that's one place. Another place is, add all. So that's another place. There's a couple other places too, you'll see later. Whenever you got a loop, you have a couple of choices. One choice you could use would be to use an iterator. So that's one way to do things, using the Java iterator mechanism, where you have an iterator and then you say, next and has next and all this good stuff. An alternative way to do things, which is what I show here, is to use a for each loop. So given a choice between an iterator and a for each loop, I would recommend you use a for each loop. And I forgot to mention that to you this morning. And the reason for that is it's just a little cleaner. So for each loop, when it's usable, makes the code nice and concise. And so what this is doing is it's using a for each loop to loop through every element in the collection. And so for each element T of type T, we're going to do something. In this case, we're going to accept it. So given a choice, use a for each loop rather than an iterator, because there's less syntax to have to remember than have to type. If you forget to do that, it doesn't make your program wrong. I will probably just tell you in my comments, please replace the use of explicit iterators with using a for each loop. It turns out that there are cases where using iterators are preferable to using for each loops, but this is not such a situation. Okay, so that's basically that's a summary of the 5 key functional interfaces that we're going to focus on in this class. And the reason why I focus on those 5, predicate, function, bifunction, supplier, and consumer, is when we get a little further along, we start talking about things like streams. You'll see that those are the APIs that are passed around a lot in streams. So knowing what those interfaces are is very helpful. There's a few other things about functional interfaces I want to talk about that are just interesting to know. We've shed a little light on this in our earlier discussions, but I want to codify it in one place. So the key thing to remember is functional interfaces may also have other kinds of methods in them, such as default methods and static methods. So here, for instance, and you can read more about that here if you read about some of the stuff that's described at this link. So we're going to look at something called comparator. Comparator is a standard Java class library class which defines a comparison function used by various other parts of Java, such as sorting and so on, in order to impose a total ordering on a collection of objects. So you use this whenever you want to compare various elements in a collection to see what their ordering relationships are. So that's what a comparator is. Here is the abstract method in this functional interface. So compare is the method. You can see it takes 2 parameters, O1 and O2 of type T, which is the parameter. And the idea is it's going to compare them. If they're equal, it'll return 0. If T1 is, or O1 is greater than O2, it'll return a value greater than 0. If O1 is less than O2, it'll return a value less than 0. That's just for your information. You don't have to know that too much at the moment. Here is a default method called reversed. And this will take this will use the comparator, but it'll reverse the order of the comparisons. So less than becomes greater than, and so on. Obviously, if they're equal, it doesn't reverse anything, but that's what reverse does. So it's got a default implementation reversed. There's also a static method here called reverse order. And in this particular case, it provides and implementation when used in a static way. The main difference between default methods and static methods is that the default method can be overridden. If you were crazy enough to want to change what the default behavior of reversed was, you could, whereas static methods only have a single implementation. So that's the one and only implementation of this. Now, here's a really, really obscure piece of trivia about Java 8. So remember I've been telling you that a functional interface, by definition, has a single abstract, only a single abstract method. It could have other methods. It could have other default methods. It could have other static methods and so on. But it can only have a single abstract method. Well, when you look at the comparator interface, lo and behold, there's this second abstract method in here called equals. What the heck is going on? Was I misleading you before? Well, not really. The rule here is that if you have an interface that, and all interfaces have the potential to override methods defined in the class java.lang.object. If you have an interface that overrides one of the methods from java.lang.object, then, or not overrides is the wrong word, redefines or defines one of those things, that doesn't count as part of the interface's abstract method count. So this is steeped in mystery and lore of how Java was originally designed. Originally, Java didn't have some of these concepts like default interfaces or default methods and so on. And they had this class called java.lang.object, which, as you may know, everything in Java implicitly extends java.lang.object. It's the root of everything, even though you don't have to explicitly say it. It's just the way it works. So as a result, they had to do special case processing semantics for java.lang.object. So in this case, comparator needs you to implement both compare and equals. And so it basically gets the equals interface from, or the equals signature from the java.lang.object class implicitly and can enforce you to override equals. But it doesn't count towards this being an abstract method, and therefore comparator is still a functional interface because this is the only method that it defines that's important. And compare is not actually defined in java.lang.object. Yes? Yes, the good question. Is there a reason for only one abstract method? Yes, because that's what allows the lambda expressions and method references to work properly because they're implicit. They don't require you to explicitly name the methods. Remember, whenever you use a lambda expression, you don't have to give the name of anything. And the reason you don't have to give the name, you just give an expression, is because it knows, since it's a functional interface, there can only be one method that's abstract that this expression could relate to. So that's the reason that it works that way. That's a little bit obscure, so let me go back and show you an example to make it a little bit more clear. We'll use this one just for sake of argument. So as you can see here, we're passing in, let's see, actually I want to find an expression, not a method reference. We may have to go back a ways. Let's see, go back and find something. Yeah, this is probably as good as anything. So you'll notice here, to supply a sink, we pass a supplier lambda expression, right? You don't see, there's no method name referenced here. It's just some code using the funky lambda expression syntax, right? Open, close, arrow, open curly brace, a lot of code, close curly brace. That's all you see, right? And so if we go look at the supply a sink method that's part of completable future, you'll see it takes a supplier. And if we poke a little further down here, you'll see eventually the get method gets called. This code over here doesn't say anything about get. We don't reference the get name. So if a functional interface could have more than one abstract method, then how on earth would the compiler really know that this is what it was referring to? So just to make life easier, there would be ways to do it if you had different types and so on, but just keep sanity in the understanding process. A functional interface has only one method, therefore we know that the method that's going to represent this lambda expression, or going to express or realize this lambda expression, is the one and only method, which in this case would be get. So that's why there can only be one. That's why I had the Highlander movie reference. There can only be one earlier. But yeah, that's a really good question. Okay, so I think that is basically the end of this. I just was pointing out that, oddly enough, you can have more than one method that's abstract, as long as the second or third or whatever is something that comes from the java.lang.object superclass that everybody has to implement implicitly. Okay, any questions about functional interfaces at this point? Do not worry if it didn't all make perfect sense. By the time you get a chance to implement the programming assignment, it'll become a lot more clear. And by the time we go through lots more examples in the class, it'll become a lot more clear as well.